Good afternoon, Rotarians. It's my pleasure to introduce Rod Branson to you today. I've got to say that it was an unusual situation as far as I'm concerned. I was at reception and Rod was on giving out the name tags. We started to talk about what he's going to talk about today. And I said, that'd be fantastic to talk about at Rotary. And I said, would you give a presentation? He said, yes. So it went from there. And I've got to say that I was so impressed with his knowledge of the industry. It was, I really was. I know very little about it, but I've got to say that I think power is a major issue we've got in society today. I think we have two major things. Water and electricity we need to survive today. And I think the thing is, this is the thing that we haven't been really looking at overall from governments and things like this. And I think the governments have lost their way with power. And I'd like to now introduce Rod to you. Thank you very much indeed. Thank you.
Thank you very much, Laurie, and hello to everybody. It's a great pleasure to be here talking about something I know a bit about. I'm going to read read my speech because if I try to ad-lib it, I think I'm going to spend too much time. Some might say that I'd waffle. Let's see if we can get this up. Okay, how do we maximise it here? Down the bottom here somewhere. There? No? Yep, got it. Okay, good. For those of you who haven't spoken to me and understand some of my background, I've been 55 years in the energy industry, which seems like a short time to me. It's been one heck of a ride, and it's taken me from, to a lot of places, but from one end of the production facilities to the other. I've had direct responsibility for everything from drilling holes in the ground offshore to a retail operation, selling gas to everybody. So it's been a fun ride in covering everything. The first thing I want to do is comment that I'm going to share with you what others are dealing with along the road these days. And because I'm involved, as I said, in this industry, I'm going to just hit the highlights, as it were, because it would take too much time otherwise. The impression that is shared by many I speak with is that Australians are having their living conditions adversely affected by myopic and idealistic adherence of a few leaders to emissions reductions which are disconcertingly unrealistic. All the issues need to be dealt with simultaneously, hence we need a composite response, and that response must be balanced and not driven by ideology alone. I am of the view that at present it's not balanced. First, I want to talk about something that is important as background. We derive an immense amount of our income, national income, from exporting energy. As a nation, we're the largest coal exporter in the world, both of thermal and metallurgical coal. We're the second largest LNG exporter in the world, supplying countries that need our energy for their wealth. We're the third largest exporter of uranium to the world, which is used for nuclear power by others. We're the third largest minerals exporter, and mining needs explosives, and explosives are made from natural gas. We're the largest barley exporter in the world and the third largest wheat exporter, and grain farmers need fertiliser, and fertiliser is made from natural gas. So why should we cease energy-related activities which are part of what makes us wealthy, and in so doing permit other nations to gain a competitive advantage? We need to keep doing what we do well. Let's turn first to carbon dioxide because it's a pretty sensitive subject and much debated. And I ask the questions, why not methane? It comes from 2.6 billion cattle, sheep and goats in the world. And why not water vapour? Water vapour actually has a greater impact on global warming than carbon dioxide. And incidentally, in the world today, there's about 7 billion more people than there was about 1810. And each of us breathes out 400 grams of water vapour every day. So every day there's 2.8 million tonnes more water circulating through the atmosphere. The answer to my question is that we can do something about carbon dioxide. Dry air is comprised of just 412 parts per million of carbon dioxide. But in the year 2000 it was 370. So that rapid rise is what creates concern. Today, an emitter of carbon dioxide is encouraged by the government to purchase ACCUs, Australian Carbon Credit Unit. And they purchase it from a registered enterprise, which may be a forest, a wheat farm, or a depleted underground gas or oil field. There's a cap on the price of an ACCU, and it starts at $75 a tonne and will increase each year. But $75 a tonne is far too low. The price is not sufficient to cover the cost of developing a facility to capture and sequester carbon dioxide. In the industries with which I am familiar, there are 215 businesses who are described as being covered under a safeguard mechanism, which is within a federal law. They emit 100,000 tonnes of carbon dioxide per year and are obliged to reduce their emissions intensity by 4.9% per year. That's not easy and it's expensive, but action is taking place. Chevron, Santos and Beach Energy have been or are working on capture and storage projects, and I've been working on one of those. Let's turn to natural gas. Price caps are in place on natural gas, along with other controls. Hence, there is little encouragement for gas exploration and development. Gas supply is or will be affected. As a result, it's fair to say the gas market is presently artificially distorted. Gas has to be in the energy supply mix for at least another 30 years because our vast construction industry needs cement, clay bricks and glass, all of which are made using natural gas. Our food industry relies on natural gas for making bottles and bakery products and for careful thermal control of many processes. Natural gas has a consistent flame speed and a consistent heating value which is critical for temperature control in many industrial and manufacturing applications, particularly in ceramics. All equipment using natural gas has burners which are physically configured to burn natural gas or separately LPG. To convert those burners to use another gaseous fuel will cost you, the owner. Crude oil, maybe a dirty word, maybe a dirty product, but let me assure you that I've had an important but close association with crude for a lot of my career. At one stage, I ran all the platforms in Bass Strait, and we were producing at that time 500,000 barrels a day of crude, which provided 2/3 of Australia's requirements, and 90% of the gasoline came from that. So you could understand why we were regarded as a vital national installation, and we had a lot of people looking over our shoulder. At the same time, it was. I look back on it and think that was a lot of fun. A lot of responsibility, but a lot of fun. But pause for a moment and think of the immense lifestyle transition that took place after crude oil was first produced and used in the late 1800s. Today, many items are made from the chemical conversion of naturally occurring components of crude oil, or that have been separated from crude oil. Included is a mammoth list of everyday articles which are made from plastics, including PVC, polyethylene, polyurethane and polystyrene. Much of the criticism of the oil industry is ill-conceived and some of it is ironic. For example, the waterproof jackets that the climate protesters clad themselves in to save from being drenched by the fire hoses are actually made from crude oil. Crude oil is essential for lubricants in machinery, in our own motor vehicles, aeroplane engines, and the large gearboxes that are in the housing sitting atop those giant windmills. So we all need crude oil for a whole lot of reasons, and we will need to have it in the mix until such time as something else can replace it. Coal and electricity is part of the integrated mix. The use of coal for generating electric power must not diminish rapidly. We need the baseload power that coal-fired plants provide, as only gas can do the same, but at a higher cost. Renewables with batteries cannot, but they can supplement. They all need to be in the supply mix. An example of the significance of baseload power is the smelting of alumina to produce aluminium. It requires a very large amount of electric power, reliable electric power. At Portland, in Victoria, Alcoa uses 8% of Victoria's power. At Tomago, in New South Wales, Rio Tinto uses 12% of New South Wales' power. To operate, they run 24 hours, 7 days a week, and if the power fails, the smelting pots and their solidified contents have to be discarded. That's extremely expensive. A decade or so ago, on a consulting assignment, I learned that there were 25,000 coal mines in China. I know the reason for that, but I won't go into that at the moment. Based on reported tonnages, at least half remain in production. Some of the mines feed 2,500 coal-fired power stations. If you look closely, and I know it's small print, but that red bar on the left shows 2,363 existing coal mines in China. Existing power stations, which are coal-fired. And they're still building more coal-fired power stations. And as the cartoon depicts, we just have less than 20. And I should add that with China having 2,000 coal-fired power stations and us less than 20, China emits 30.9% of the world's carbon dioxide, and we emit about 1.1%. I say we don't need to rush to get rid of our coal-fired power stations. Okay, green electric power. An aspect of energy transition that seems to be a favourite topic of so many so-called experts. And I'll refrain from defining what I call an expert. Yes, we can build solar arrays and we can install wind-driven generators, but there are challenges and they're all too often ignored or dismissed by our political leaders and green power advocates alike. But then again, maybe they're experts. So hence the question is, what will it take to go green? Our federal minister has said that to reach the legislated 2030 target of 83% renewables for electricity, it will require to make operational 22,500 megawatt solar panels every day for 8 years and 47 megawatt wind turbines every month. Surely manufacturing and constructing those items in the time frame is bordering on being ludicrous. But the Minister asserts there is no reason Australia cannot do it. Solar arrays and wind turbines are never likely to be located close to load centres, they're never likely to be located close to existing power lines, and they need to be connected by poles and overhead wires across farmland. The Rewiring the Nations program carries estimates of a need for 10,275 kilovolt poles and wires by 2030 and 28,000 by 2050, with an estimated cost of not less than $20 billion. I'm also aware that under the Renewables Energy Act, each wind turbine installed in Australia attracts as much as $600,000 per year from the Australian government. One estimates that the government funded cost at $40 billion. To this I must add that the biggest wind turbine in the world generates just 8 megawatts. That's the biggest wind turbine. And it is very big. It has 167 metre diameter propeller, and if you compare that with the tallest building in Adelaide, which is 138 metres, you can add another 17 floors on that building to get to the top of the windmill. And lastly, about 40 big propellers, each driving an 8 megawatt generator, provides about the same as one small modular nuclear reactor. One reactor. And where will the government get that 40 billion and the 20 billion? Well, yes, it's you and I, the taxpayers. And now to nuclear. Many people I speak with say nuclear power as a source of energy must be in the future mix. The emotional and often ill-informed chatter needs to be replaced by logic and be based on what has been obviously achieved since man first controlled nuclear fission 78 years ago. We and 7 nations in Europe as well as the USA are contemplating SMR, small modular reactors, with each one about 300 megs. China and Russia both operate prototypes, while 17 other countries are scrambling to develop and use the technology. USA, its one small modular reactor is due to enter service in 2026. Excuse me. Nuclear power is being generated in 10 countries, with USA, France, China and Japan having the largest output. And with the benefit of hindsight, Germany regrets having shut down its 17 nuclear reactors, and it now struggles to meet both its power demands and its emission goals. I find it a paradox bordering on silliness to think that Australia is not using its own fuel to meet its own power needs and its emission targets, while at the same time shipping uranium to other nations who are doing just that. I must add that the life cycle costs, and that's emphasised, the life cycle costs for small modular reactors and wind are identical. So I don't want to hear ill-informed costing comments about nuclear. The grossly distorted nuclear waste issue is solvable. France has done it, and they're running all those power stations. And there would be no landscapes blighted by enormous wind turbines and arable land laid waste by hectare upon hectare of solar panels. To that we can add the 28,000 kilometre of high voltage transmission power lines needed to connect all these silly little power stations to the national grid. Mankind knows what to do with nuclear to be successful. Hydrogen, and will it be part of the energy mosaic? Hydrogen can be converted to a liquid at minus 253 degrees, and that's a lot colder than LNG, which is minus 162. To achieve liquefaction requires a huge amount of heat energy, and for transport it would require an absurd amount of insulation to eliminate all the heat ingress. Hence, it would be impractical to build a suitable ship that could economically transport liquid hydrogen to Japan or Korea Hydrogen can be converted to ammonia and liquefied for shipment. Each option is technically feasible, but the sequence of steps makes the total concept a completely non-competitive option. I'm being very polite in that comment. Metallurgy presents a challenge. At high pressures typically used, an atom of hydrogen can penetrate steel by migrating along the naturally occurring grain boundaries. And in my industry, the industry I've been involved in, I'm aware of a hydrogen embrittlement disaster resulting from this. Alloys can be used for the containers, or pressure vessels can be lined, but both of those things add to the cost. Then there's the characteristic that scares the hell out of me. The flammability range of natural gas is narrow. It's 5 to 15% in air. But hydrogen is very wide. It's 4 to 74% in air. Hence, handling it poses inherently more risk. For decades, I've been responsible for facilities handling natural gas at 70 atmospheres, 1,000 psi plus, and a whole lot of low pressures as well. And I've always treated it with the greatest respect. In my view, hydrogen is in another ballpark. Hydrogen up everyone's street will never occur. Its unsuitability results from the combination of what I've already said, as well as being a gas with a lower heating value, which would create delivery and combustion problems. However, it's possible for it to be mixed with natural gas. So in my view, hydrogen is a furphy. Like the horse-drawn water tank, which brought water to the frontline troops in World War I, it may arrive, but then again it may not. And the corollary to that is the driver of the horse didn't make it. Finally, and I'm mindful of time, whoops, wrong way. There we go, nearly there. Finally, no one I speak with is suggesting we do nothing. However, it seems to me that what our political leaders are suggesting we can do amounts to the complex work and the risks to us, the passengers, of rewiring the electronic controls on a tried and proven Boeing 747 while it's in flight. Surely a more realistic approach is needed. And yet our Federal Minister has repeatedly said, I will not accept that we cannot do what is needed to achieve our emission goals. Well, the speed of change needs to take into account the capability and cost to deliver, and it needs to take into account the type of changes needed with multiple consequences, not just singular. As a nation, we must not change just to achieve an emission reduction target, which was established on the basis of short-duration data. This is particularly so because the estimates of the cost to do so are eye-watering in size. One recent study concluded that for Australia to decarbonise, $1.5 trillion needs to be spent by 2030. That's $5 billion per week, every week for the next 6 years. I have a pretty good idea because I've worked on a project where we spent 10 million US a day, and that's hard to manage. Another source indicates 3 trillion by 2050 and yet another 9 trillion by 2060. Lord knows where the money's going to come from, but it's probably us. The actual number is obviously not precise, but whatever it is, the dollars will be paid by us, the people of Australia, whether directly in taxes or because of the penalties Australia incurs when our national credit rating goes down and our federal treasury has to pay higher interest rates when it borrows funds. There's a huge amount to direct, control and execute, and some of it, sadly, is already misguided. Thank you.
I think it's very thought-evoking, isn't it, with what's happening with our power supplies in Australia. Is there any people who would like to ask a question of Rod?
Grant. Thanks, Rod. I really appreciated your presentation there. One of the questions I have, and I don't doubt that nuclear is a viable alternative theoretically, do you believe it's viable socially in that we just have, excuse me, the medical waste, which is low-level radioactive waste, that's currently stored in the basements of hospitals, which, you know, people don't know when they're going to hospital that that's where things are stored, because as a nation we were unable to find a way of storing that. There was the one out at Kimber that was recently proposed that's just been overruled by the High Court. Yep. So I can't see us ever getting nuclear up in Australia due to the Australian people, not due to the technical aspects, but due to the social aspects. What's your comments there, please, Rod?
Not an easy one to answer because it's social, of course. But one of the things that we must do is not say we can't do it. We have to have the debate, and let's be open and frank with the debate and try and get the emotion out of it. But the first thing that has to happen, there's actually a law, a federal law, that prohibits nuclear power in Australia. So the first thing that we have to do is to persuade the politicians to repeal that law. Until that happens, we will not have nuclear power. But I still maintain that we have to have nuclear power if we are to not blight our landscape with solar panels and windmills and power lines. I mean, none of that would happen if we had nuclear power. And, okay. Yep.
Thanks, Rod. As you know, I'm pretty passionate about this topic as well. And I think that was excellent. I think it will be compelling for Australia to adopt nuclear power. It will be no option. Now, we've got coming up, looming around the planet, 1 billion solar panels that have got to be removed and replaced by the year 2030. I endorse and suggest anyone that's interested to watch a Michael Moore program called Planet of the Humans. Now, Michael Moore, for any of your interest, is actually pretty left-wing, but it's worth watching this program. It goes for about 2 hours. It's quite interesting and insightful and talks about what they're doing in the US and burning trees. They see that as wonderful to put carbon dioxide in the atmosphere because it's replenishable. You can grow another forest. So that's fact today in the United States. So in this world, I think there's so much confusion. I think our our federal politicians, and I mentioned this to Tony Zappia when he was here only a few weeks, or probably 5 weeks ago. I made the comment that both successive coalition and Labor governments, I think, have let this country down badly. We've given away one of our natural resource attributes of energy. We're trying to be at the altar of world parity pricing. It's a disaster. We're going to see that roll out this summer. Prices have gone up astronomically, and I can give an example where we sought to quote on our property. It was a 584% increase. So we now buy from the wholesale market. And the interesting thing is we're putting in diesel generators to make 24/7 irrigation on our property so that we can avoid the peaks of the wholesale market. That's the world we're in today in this country. It is absurd. Anyway, thank you again. And I do think that nuclear will be compelling because the options just aren't there. The other thing that you didn't really mention is transmission. When they're talking about spending 30 or 40 billion putting in transmission, if you put these small little nuclear reactors into where the old coal-fired power stations are, you've already got your transmission. Anyway, and
totally
the new fans going off Hunter Valley, my mother's from New South Wales, they're going to put 500 hectares is set up for that zone. It's over the horizon so we won't see it. Those fans are going to be taller than Sydney Harbour Bridge. Think about that. And there's going to be lots of them. And are they going to hurt wildlife? The Greenies are saying nothing. It's bizarre.
One more question.
Thanks, Rod, for your comment. I love the presentation. My son Andrew, who has addressed this club in the past, who was, you may know him from Santos when he was CFO there. He is now CEO of Australian Naval Infrastructure, which is building the new shipyard in Port Adelaide.
Yep.
And about 3 weeks ago, he was in Rolls-Royce after he'd been to Holy Loch or wherever the submarines are being built. and he saw them building a modular reactor, you know, sort of 10 or 12 feet in diameter and maybe 16 feet high, and these will go in each of the submarines that we get whenever we get them. And he dropped a couple of numbers on me the other day that then was referring to the disposal of nuclear waste, that each one of those modular reactors inside an American or British BEA submarine, about less than a cubic foot of it, cubic foot, will power one of those submarines, continuous power for 30 years.
Yep. Yes.
That sink in.
I thought it was 40, but
And that puts some of these objectors to nuclear waste into context.
Yeah.
And if the question then comes, can we get as a nation which has done things like the Snowy and worked with the Americans and beaten the Japanese, for 1.2 trillion or whatever it was, $1 trillion, surely our nation can put together a business task force which can get us ready to absorb nuclear power.
Thank you, John. Anyhow, I'd like to sort of, because we're running out of time, is the fact that I think it was fantastic what he spoke about, and I've got to agree, I'm biased towards what he's saying, and I'd like to thank him in the normal way that we do. Thank you very much, Rod.